Hi, in this part we deal with Boolean expressions and operators. We are going to have some examples of good practices when we name Boolean variables, be introduced to De Morgan's law, and some examples of more complicated Boolean expressions. I'm going to introduce the truth table, which may be useful if you want to understand or you want to evaluate a more complex Boolean expression. Now let's start with naming conventions. The convention here is that when you choose a name for a Boolean variable, it'd be nice to choose a name which gives the reader an obvious idea of what this variable means. So it is common to choose a name called is something, is logged, is processed, is mail, is updated. For example, for example, you can have a person class and an attribute can be is male to represent the sex of that person. Boolean type, of course. Let's assume a person can only be male and female and nothing in between. So, if is male is true, that means the person is a male. If is male is false, that means the person is a female. Okay, no intermediate. So this name Ismail is is a good name because it's easy to understand. All right. Or if you prefer, you can use is female. Just choose one of them to represent the sex of that person. So is locked can be a good Boolean attribute for, let's say, a cupboard. So a cupboard can exist in either locked or unlocked state and nothing in between. So if is locked is true, that means the cupboard is locked. Otherwise, if is locked is false, that means the cupboard is unlocked. Here's an example of a method name which returns a Boolean, contains digits. Probably this can be a method in a string class. So when you call contains digits, you return true or false depending on whether that string contains numbers. So look at the name of this method. It is very clear what it does. Okay, choose a good descriptive name for Boolean attributes and methods. A, B, C, I, J, these are very bad names because you have no idea what they mean. Look at these few expressions, they are the same. Look at these two. Not A is the same as A. So please don't do double negation unless there's a really good reason. Alright, look at these three expressions. Not B is true. Is the same as B is not true. Is the same as B is false. Look at these three expressions. If that if you have a choose the third one because the third one is very easy to understand. You don't have to twist your mind and think about knots. Alright, look at these two. C equals false is the same as not C. Alright, let me give an example. If C equals to false, do something. This is the same as if not C, do something. These two expressions are identical. This is not wrong. It is easy to read and understand, but this is um, probably easier to read and understand. It may not be obvious in this case. Why? Because I chose a very bad name, C. Let me choose a good name for booleans and you understand why this is slightly more preferable. If is male equals to false versus if not is male. Look at this. I want to go into the if block if the person is a female. Okay. So if is male is false, that means that person is a female, I'll go into the if block. Look at this. If not is male, isn't that very intuitive? It means that person is a female. Go into the if block. But anyway, both are fine. Alright. Look at the fourth bullet point here. These two are also the same. D equals true is the same as D. If is male equals to true, process male. If is male, process male. These two expressions are identical. So obviously you should choose this. Although this is not wrong. It's not difficult to understand as well, but it really is unnecessary. Okay? Now, I'm going to introduce the truth table. You may not have heard of it. Let's see what is the truth table. Let's start with the truth table for N and all. Okay, the N truth table. So A and B. What do I mean by the AND operator? Only when both A and B are true will the expression A and B be true. So the truth table, by the way, there are, oh, I have one missing one missing row here, but doesn't matter. There are only four possible combinations of A's and B's. True, 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 false, false, true, and false, false. Okay, because there are only two variables, there are only four possible combinations. If A and B are true, both true, A and B, this expression will be true. If either one is false, this expression will be false. If both are false, A and B will also be false. So this is the truth table for the AND operator. What about the OR operator? Okay, the truth table. A or B. So let me construct the truth table. So if A is true and B is true, A or B will be true. Okay, OR means either one is true. But if both are false, A or B is false. Now the truth table, it might be useful for complex expressions. Okay, that's why I noted here. Use a truth table to evaluate more complicated expressions. This is an example. Okay, how do we know when this expression is true or false in the different situations for A, B, and C? So the expression is A, N, and B, or C. Am I correct? Let's check. Yep. Now, if you check the precedence table, these two operators have the same precedence or the same priority, which means that we evaluate from the left to the right, which means that a pair of brackets will be implicitly inserted there. So, um, by the way, there are actually three variables now, A, B, and C. So which means that there are 8 possible cases, 8 possible combinations. True, true. 2, 3, 4, 5, 6, 7. I have one missing column as well. So this will be true, false, false, true, false, false. And I'll copy this whole chunk to the bottom here. So true, true, false, false. True, false, true, false. So these are the 8 possible cases for the different values of A, B, and C. Now let me insert a column for A and B. And this will be the expression itself. A and B or C. Alright, so A and B, I'll just have to look at these two columns. I'm going to ignore the third column for now. So A and B, true, 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 false, true, false. Remember, I'm dealing with the AND operator. False. Once I see false, I won't bother. Once I see false, I won't bother. You definitely be false. Okay. So what about this? A and B or C. So I already have this expression, right? By looking at this column, I do not have to look at A and B anymore. In order to fill in the values for this column, I only have to consider two columns, this column and this column. Okay? So I'm dealing with the OR operator. I just have to OR this column, the third column, and the fourth column. Okay, so true and true, true or true, it's true. False, true, true. I'm dealing with OR operator, so once I see a T in either of these columns, right, I'll just put a true. True. False and false or false? Nope. True, false, false. Nope. So this column is your expression's value. Okay, that means the value of this expression when A, B, and C, okay, contains these values. So immediately, just by looking at this truth table, someone asks, if A is true, B is true, and C is false. A is true, B is true, and C is false. Alright, the expression will be true. Just by looking at this truth table. So sometimes it may be worth the effort to construct a truth table. Sometimes the expression is not complex enough to spend effort on it. You can try to construct your truth table for this expression. Okay, remember, not A is simply the opposite of A. Okay, if A is true, not A is false. If A is false, not A is true. Of course, in this case, there are only two operands here, right? So this returns true or false depending on whether I is even or odd. So if I is a even number, an even number mod 2 will give you no remainder. Alright, so this expression is true if I is even. Otherwise, the expression is false if I is the expression will be false if I is odd. In this one, j divided by 5 is more than 10. Okay. Now, a very quick note about De Morgan's law. If you do a search on the internet, okay, a lot of material about De Morgan's law. Basically, there are two rules. This expression, P and Q are both Boolean variables, is the same as this. They are equivalent. This expression is the same as this. Now, to verify this for yourself, you can just simply draw a truth table, correct? You're dealing with only two variables, P and Q, so it's not too bad. Because there are only four cases, right? True, 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 false, false, true, and false, false. Okay, and you can try to evaluate this. Not P and Q. If you find this difficult to evaluate, you can do it in two steps. In other words, you have a column for P and Q, and you have a column for not P and Q, which is the opposite of this value. The opposite of this value. And then you can do this. Okay? And you realize that these two values will always be the same. Okay, you can do a quick practice. I will draw a truth table. Okay. Similarly, for the second rule, you can draw a truth table for this expression. They will be the same. Okay. Now, in the next video, next topic, right, Joel will talk. There's a part about with more information about the Morgan's law over there. So this is the end of this session.